What are identifiers and examples? You have seen many times declaring variables int a or float b. Likewise, you have the names for classes, derived types, names for enumerators, names for structures. So all these are called identifiers. So for a particular definition, if you are looking for interview answer, an identifier is a sequence of characters used to denote one of the following: object or variable name, class, structure, union or enumeration. All types of data types, basic or derived. When you give a name to it, right? So that is when you bind a name to the data type, that becomes your identifier. Now you take a look at an example. Right? So if you say a simple example of int a, this a is an identifier. And then likewise, if you have a class, right? So if you have a class vsd, and then you have an object obj, so this obj is your identifier. Well, so likewise, you can declare identifiers for enumerators, for basic data types, whatnot. What is the size of the class, the object, and a pointer to object? This is going to be, very interesting, in the sense that you guess it is, the same as data types and all, but you see what magic happens. Class size is equal to the total size of data members. That is very clear, and we will also see the variance of that. Then the next important thing to note when you are asked is the object size is same as that of the class size too. And then your pointer object size is no different from the object size as well, right? So let us see what it looks like with the help of a program. Well, so here you see a class called class name, and then it has one integer data type and one pointer type, right? So, and there are no functions in it. You are coming to the main function. You have declared an object of the class type class name, and then you have declared a pointer to an object and allocated memory to it as well. Now let us see, the first statement says size of the object dot data, which is integer, and then we are getting the general size of an integer data type as such. The next one is size of an integer pointer that has been declared inside the class, and next is your size of integer pointer. Okay, I think I have written it twice. Fine. Then the size of the class, then the size of the object, then the size of the pointer to object. Then few more, like you allocated a memory to the pointer integer which is inside the class of 100 bytes, and then you are getting the size of the class and object. Let's see what happens. So I have compiled, built the application. Now here you see the output. Size of an object dot data is integer, this one. So integer and size of integer is 4. So therefore it is clear the same as the integer data type. And then the next size of integer pointer is 8 bytes. So here it allocated for a pointer data type, it is 8 bytes. Now what I am using is a Visual C++ compiler which follows the standard of C++ 14. And then size of a class 16. So here when I print the size of the class, which is coming 16 bytes. Why is it 16 bytes? It is clear. So 8 plus 4, one data type and one pointer, which is 12 bytes, right? 8 and 4, 12, and yet you get it as 16. Interesting? Yeah, we will see what it is. And the next one, what you are printing is the size of the object is also 16, and the pointer object, because you are printing the pointer which is 8 bytes, not the size of the real object, you are printing the pointer here. And then you have allocated memory of 100 bytes, and then you have class after dynamic memory allocation is 16 bytes. And then even size of the object after dynamic memory allocation 16 bytes. So because the size of the object is of your what is on the stack frame, and when you may allocate dynamically, it is going to be allocated on the heap, right? So that is no uncertain at the time of fetching the this memory. So therefore when you measure the object size, it only gives you what is there on the stack frame. It does not include the dynamically allocated memory. Now what is this confusion? Let us go back. So object.data, only one member variable 4 bytes, one member variable pointer 8 bytes. So the class size is supposed to be 12 and it has come 16. That is because your padding, right. So that is another very important interview question, we will cover it up. Now if I have to say int data 2, right, if you get the data, if you now you compile and get the sizes, it will remain same 4, 4, 8 and 16. It didn't change. You see, even after you added one more, it didn't change. That is because even though this member variable is not there, in order to allocate memory proportionately, the runtime does the padding part of it. Now if I declare another variable, now you compile and see what happens. You see, it became 24, right, whereas the data is only 4 bytes. So 16 plus 4, it is supposed to be 20, but it throws saying 24. So that is because of the padding for the memory alignment. We will take that as a separate question. So hope this gave you clarity on the sizes of data types, the basic data types, derived data types, and pointer data types as well. Consider arrays, lists, maps, trees, and priority queues as abstract data types? Yes, the answer is pretty straightforward. What is scope? Scope, we have, as you see, usually it begins and ends with a curly brace, right? So whatever you write inside the scope, or all the data types, member variables that you write inside the scope, they are going to live for this duration. So when the control begins here, it takes the birth, and then control leaves the curly brace, it dies. In fact, it's not as soon as it begins, the life begins. But when you have a member variable like so int a, right, and then followed by int b. So the int a begins at this instruction, the line number, and then int b doesn't take life as soon as you begin this, right. So when you come to the int b statement, only then it takes life. So if you, without declaring, if you try to accept, because the scope is anyway throughout the block, can you access this int b here, see out, let's say a b? No, you can't, because the information is not available at this line about variable b. So therefore it is from the declaration of the member variable to the end of that particular block. So in a definition terms, a region that limits the life of identifiers. A namespace, and provide an example. Yes. So namespace is a declarative region. That means you want to declare a region and limit the scope of it. Like in the scope, in general, the scope usually begins and ends with the curly brackets. Now, when you do not want to be bound by the curly brackets, see, curly brackets either have to be inside a class or inside a function definition. So they have a particular pre-assigned region which you have to limit yourself. But namespace, let's say if you want to make several classes and functions into one namespace, so that you can uniquely identify it. If two developers are working on one project and they are both building, one is building the basic calculator and the other one is building a advanced calculator, they both might end up writing add method into the same class. Whereas, when you merge, when you combine them and build, you see the errors. So to avoid that, you can give a namespace for the basic calculator as basic calculator as a namespace, and for the advanced one you can give the name as advanced calculator. Therefore, when you use them, you can first use the namespace basic calculator and then use the advanced calculator, even though the function names are same, class names are same, because their scope is inside the namespace, you would restrict the region. So therefore, it is a declarative region that provides scope to the identifiers. Let us look at the code part. If you look at the program, the namespace basic calc is declared, right, and there is a region for it, and there is another namespace called advanced calculation, and then you have another class. So the class names are same, and so when you come to main, right, you see how we are using it. We are using a scope resolution operator and the namespace, class name, and then the basic object. So you declared an object of type addition which belongs to basic calc namespace. And likewise, you have advanced object which belongs to addition class, which belongs to advanced calculator namespace. So this is how you make use of it. And now onwards, you can use anyway basic object dot add, advanced object dot all the member functions. So here another way, if you say using namespace basic calc, right, you don't need to repeat these namespace name scope resolution. You can directly say addition basic obj1. But anyway, so if you are using this, you cannot use both of them and try to call addition. Then there will be an ambiguity. So whenever you need the particular namespace type, you can just say using namespace basic calc and then go ahead. If you want to switch to it and then again write the using namespace advanced calc and then start using that particular namespace and its classes.